Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized pieces for your brain. Today, we're diving into the world of AI developers.
That's right. We have these incredible AI tools now, often called code agents, that can look at a huge software project, find a bug, and actually write the code to fix it. It feels like magic.
It really does. But today's paper asks a crucial question. How robust are these AI agents? Are they really understanding the code like a human programmer would? Or are they just very, very good at recognizing patterns? And what happens if you slightly change those patterns?
This paper, titled A Jagged Frontier, puts them to the test. The researchers designed a clever, almost mischievous experiment. They took real-world software repositories with known bugs and asked different AI agents to fix them, but there was a twist.
The twist is that they also created slightly altered versions of the same code. They made changes that a human programmer would instantly recognize as meaningless. Imagine you have a variable in your code called user_name. The researchers might change it to name of user.
Exactly. The code looks different, but it does the exact same thing. The meaning, or the semantics, is preserved. They call these semantics-preserving transformations, or SPTs for short.
They did a bunch of these. They'd swap the order of an if-else block or add a line of code that does nothing and is never even run, what programmers call dead code. The goal was to see if these superficial changes would confuse the AI agents.
And it's a great way to test for true understanding. If the AI genuinely understands the logic of the code, these harmless changes shouldn't matter. But if it's just relying on surface-level patterns, it might get thrown off.
So what did they find? Did the AI agents pass the test?
Well, not exactly. The researchers found that in most cases, the AI agent's performance dropped. When faced with the slightly altered code, their success rate at fixing the bug went down, not by a massive amount, but by a statistically significant margin, in some cases by almost 7 percentage points.
So simply renaming a few things or adding some useless code was enough to make these powerful AI models stumble more often. That's fascinating. But the most interesting finding wasn't just that performance dropped, it was how it dropped.
This is where the title of the paper, A Jagged Frontier, comes in. The results were all over the place. There wasn't one AI model that was universally the most robust. A model that was really sturdy and unfazed by changes in one setup would be the most fragile and easily confused in another.
Can you give an example?
Sure, they tested several top AI models like Claude Opus and others using two different toolkits, or what they call agentic scaffolds. One model, named Quen, was one of the most robust when using a simple toolkit on one set of tests. You'd think, great, this one's a rock.
But it wasn't a rock everywhere.
Not at all. When they put that same model into a more complex toolkit, it suddenly became the most brittle of all the models. Its performance fell off a cliff. This is the jagged frontier, and AI's robustness isn't a simple, straight line. It's a spiky, unpredictable landscape of peaks and valleys that depends on the model, the tools it's using, and the code it's working on.
So you can't just look at a leaderboard and say, this is the best AI for coding. Its reliability in the real world might be completely different from its performance on a standardized test.
Precisely. The paper suggests this happens because the agents are learning shortcuts. They're not always learning the deep logic, but rather relying on superficial clues in the code.
The researchers saw this in action, right? They looked at what the agents were doing when they failed.
They did. In one case, the researchers had inserted some dead code that would never run. But this useless code contained a keyword that the AI agent was searching for to locate the bug. The agent found the decoy keyword, got completely distracted trying to work on the wrong piece of code, and ultimately failed to fix the actual issue.
It's like the AI got tricked by a red herring. And there was another hidden cost, wasn't there? Even when the agents did manage to fix the bug in the modified code.
Yes, even on the successful runs, the agents had to work harder. They took more steps and used more computational resources, what the paper calls token cost. The cost went up by as much as 23% in one configuration, so even when they get to the right answer, it's a more difficult and expensive journey for them.
So what's the big takeaway here for someone who might use these tools?
The takeaway is that we need to be cautious. These AI code agents are incredibly powerful, but they can also be surprisingly fragile. Their performance on a clean benchmark might overstate how reliable they'll be in messy, diverse, real-world code.
And the best model isn't a fixed target. The right choice depends entirely on the context. The jagged frontier means we can't just trust the marketing numbers. We have to be aware of these hidden weaknesses.
It's a fantastic piece of research because it pushes past the headline numbers and digs into the nuance of how these systems actually work and fail. It shows us that true AI reliability is a much more complicated and jagged picture than we might think.
A brilliant and important reality check for the world of AI development. That's all the time we have for today. Thanks for tuning in to Daily Papers.